So for this review worksheet, we have a couple of different things. We're going to start off by talking about area. So the formula for the area of a rectangle we know is just length times width. The formula for the area of a parallelogram is base times height. But there's a couple things that are very specific about a parallelogram. When we're trying to find the base and the height for a parallelogram, they both must be perpendicular. They must both create, can't say must today, both must create a 90-degree angle between the two. The formula for area of a triangle is base times height divided by 2. So it's very similar to the parallelogram. We still have to find a base and a height, but then we have to divide it by 2 and cutting it in half. The base and the height for a triangle must also be perpendicular, must create this 90-degree angle. When you're working on an area, you don't necessarily need every number given. For rectangles, the only two things that you need to find are the length and the width. For parallelograms, all you need to find is the base and the height, because then you just multiply the two. Triangles is the same as a parallelogram, finding a base and a height and then multiplying and dividing by 2. Moving on to surface area, when we're trying to find the area of a shape that is not one we have the formula for, what's the first thing that we need to do? So what I wanted you to think about on this one here is if we had some sort of composite figure, something where like, hey, we don't have the area or the formula for an area of a t, the first thing that we should do is we should cut it up into pieces that we do know how to find the area of, like rectangles, parallelograms, or triangles. And then how do we find that area of that shape? We cut them up, find the area of each piece, and then add them together. So the next one, how do we find surface area? Well, we have to find the area of each of the faces and add them together. It's actually very similar to a composite figure in the sense that we're finding multiple areas and then adding them together at the end. So for surface area and nets, what is a net? Well, a net is really just a two-dimensional representation of a 3D figure. It's if we were to take some magical scissors on a 3D object, cut down the sides, and lay it down flat. What are some relationships between the number of sides of a 3D figure versus the number of shapes in its corresponding net? So the number of sides of a 3D figure and the number of shapes in a net should be the same, because really, again, like I said before, for a net, we know that it's a 3D figure where we just lay down all the sides flat, so they should have the same number of shapes in the net as you have in the three-dimensional figure. Now, for the surface area of a polyhedron versus the area of all the shapes of the net should also be the same, because if we find the area of each of the pieces of the net, add them together, that is all of the faces of the three-dimensional figure, which then gives us our surface area. So for prisms, and this one was a little bit difficult because maybe the question wasn't worded super well, but for prisms, they have rectangular sides, because when we look at any sort of prism, we have two bases. So let's say if we had a triangular prism here, we have two bases that are triangles, which is the left side and the back side here. Then the sides itself of this prism are all rectangles. It's the two bases that are connected by rectangles. The pyramids always have triangular sides, because if we were to have, let's say, a square pyramid, we start with a square, which is when they only have one base, and then they all come to a point, which all of the sides of that pyramid are then just triangles. If you have any questions on any of this work here, please let me know. Otherwise, have a good day and I'll talk to you all soon.